We're going to start by redoing B real quick. Okay? Not everyone got it down. We left in a rush.
I was going to ask about it.
Okay, yeah. And I've already had the question once, so we'll redo B and get everyone on the right page here. So, tangent of 5 pi over 3. The big thing we've got to figure out is what does that match up with? Is that pi over 6, pi over 4, pi over 3? What quadrant is it in? And all of that. Okay? So, and what I kept doing yesterday is I keep kind of doing little sketches over here, right? And as I keep doing these sketches, okay, 5 pi over 3. What do we know about 5 pi over 3?
It's in quadrant 4.
And why is it in quadrant 4?
Because it's on the unit circle.
But if you don't look at the unit circle.
Because 4 pi over 3. Because pi is 180 and 2 pi is 3.
So we have pi and 2 pi is what I keep trying to remind you of, guys, right? In this problem, we're working in thirds, right? And so 1 pi is 3 pi over 3. 2 pi is going to be 6 pi over 3. I keep doing that, right? I keep hoping it'll catch on, you know, because, yeah, you look at the unit circle, you know what quadrant it's in, but there's something to be said for that skill of being able to figure out where it is, okay? Now, so in this case then, 3, 4, 5, 6, right? And so 5 pi over 3 is a quadrant 4 angle. What is the reference angle there?
Cosine.
But don't tell me 60, tell me pi over 3. In other words, what's the distance between 2 pi and 5 pi over 3? How far is this from the x-axis? And 6 pi over 3 minus 5 pi over 3 is going to be pi over 3. So to do this problem, what does our brain need to think? Our brain needs to say, okay, what is the tangent of pi over 3, or 60, in quadrant 4? Well, what do we know?
It's the square root of 3, but it's negative because all students take calculus.
Yes,
so
no?
Negative square root of 3.
Okay. All students take calculus. And so, according to my chart, which is actually up there, I went ahead and left it up there after they wrote it in. So, square root of 3. All students take calculus. We said it's in the calculus quadrant, so it's negative. Does that help?
Wait, where'd you have the square root of 3? The chart?
Tangent, pi over 3, right behind Noah's head.
60 degrees. 60 degrees.
Oh. Okay.
Ooh. You're like an outlaw.
Tangent, pi over 3. Yes? Okay.
Would you like to buy a vowel?
And this is why we need to know that chart, right?
Right.
Okay? Or be able to write it down. Okay? I give you a lot of crutches in pre-calc. In calc, you don't have the crutches. Okay?
I like crutches.
So, well, you get some crutches in pre-calc. Calc, not so much. So, and the difference is in calc, I'm preparing you for an AP test, which you don't get crutches on the AP test. You have to know this stuff. So, okay. Shall we talk secant?
Again.
Secant of negative 3 pi over 4. We'll worry about secant right later. Let's talk about negative 3 pi over 4. What?
It's minus 4 pi over 4. But it's negative 3 pi over 4, so 4th quadrant? No.
It'll be in second quadrant.
It's second quadrant.
Yeah,
Because it's going in reverse.
It'd be in.
Why don't we start with like pi and then 8 pi over 4?
1, 2, 3.
Would be first. Or 4
There you
pi
go,
over
because
4,
that's one.
because this is just not making sense.
4 pi over 4
to my left. No. It's
Okay.
going the opposite way.
It's going down.
Yeah, it's not in the city because the opposite.
So we know we're going the opposite way, yes?
Yeah.
Yeah.
Okay. Now, and this is where we really still want to work with the negatives or not, because you're hearing the confusion, right?
We don't like
Yeah.
Now, if we go negatives, this is 0, right? This is negative pi. If we're going negative, yes? And negative pi is
Negative 4 pi.
negative 4 pi over 4. So where's negative 3 pi over 4 going to be?
Quadrant 3.
Right there. So we are in quadrant 3. Now, what's the other option if that whole negative issue was a struggle for you? How can we get out of the negatives? No.
6 over 8. No. 8.
What do we add to something if we want to find another name for that same angle?
Oh, 2 pi.
We add 2 pi or 360, right?
That's yours.
So if I take negative 3 pi over 4 and I add 2 pi, yes, I'm going to add 2 pi, but what is 2 pi as a fraction in this case?
8 pi over 4.
So now, negative 3 pi over 4 plus 8 pi over 4 is 5 pi over 4. If we think positively, well, think positively. As we go this way, this is also positive 4 pi over 4, yes? It's negative pi, it's positive pi. If we think this way, it's positive 4 pi over 4, and 5 pi over 4 is going to be right past it. And so thus we have it is also 5 pi over 4. And here's the deal. I don't care how you get there, as long as you can correctly get to the fact it's in quadrant 3. You need that confidence for you. Both are legitimate. Now, what is my reference angle here? In other words, how far is this from the x-axis? First of all, I want to talk radians. Second of all, no.
45.
I used to say, here's the hint. I'm dealing in fourths.
Yeah, so it's 45.
Okay?
Because it's pi over 4.
45, but I'm not going to say 45. I'm going to say pi over 4. And here's the deal, guys. What I would just do is how far is 5 pi over 4 from 4 pi over 4? And 5 pi over 4 minus 4 pi over 4 is pi over 4, yes? Now, the first part of me says, I'm going to talk secant for a moment. So when we answer this problem, we're going to ask what is the secant of pi over 4 in quadrant 3. Now, here's the deal. What do we know? And you can just go for that, and you can just go to your chart. However, I'll be honest. When I memorize that chart, I don't memorize the second half of the chart. I memorize the first half of the chart, and then what do I know about the second half? It's the reciprocals. So my suggestion long term as we go about this is, okay, if we go back to the first half of the chart, what do we know about secant?
It's the opposite of cosine.
It's the reciprocal of cosine, yes? So the other way you can think about this is what is the reciprocal of cosine of pi over 4, and that means I'm going to just raise it to the negative 1 is how I'm going to write that. But so you can either look at the chart and say, okay, what's the secant of pi over 4, and then put the appropriate sign for quadrant 3, or just memorize the first half of the chart, or be able to write it down quickly, which is what I can do, and take cosine and flip it. So,
Negative. Because it's in the third quadrant.
and I'll be honest, I hadn't even processed positive or negative
Yeah,
yet.
neither did
So, okay. Can we agree with square root of 2?
Yes.
Talk positive and negative in a moment. And here's my thing. I know cosine of pi over 4 is square root of 2 over 2, which came from 1 over square root of 2, right? And what's the reciprocal of 1 over square root of 2? Square root of 2. Cosine and secant in quadrant 3. All students take calculus, and that does indeed make it negative.
Good job.
Are we getting there?
Okay, I got the negative things.
Okay,
I got the main answer. That was really bad.
continuing along. You get to go back to degrees for a brief moment. Cosine of 240. This one should be easier. What are your thoughts about cosine of 240?
Minus 180.
Okay, so I don't even know where I want to put this, but this one's a little bit easier, so I don't need as much room. 240 is going to be down there, yes?
Yes.
So if 240 is down there, we want to look at how far is 240 from the x-axis, which means how far is it from
180.
180. So 240 minus 180, I'm being told, is 60 degrees. What quadrant are we in?
3.
Quadrant 3.
Oh.
So my brain is asking, what is the cosine of 60 degrees in Q3?
Not looking.
Nope.
No? Yeah, Mario.
You got the other one.
Oh, that's
Cosine of 60 degrees is
Negative 1.
1/2. In quadrant 3,
Negative.
negative, I agree.
makes sense.
Ask the questions if you have them, okay? Ask them as we hit a question, because I'm just going to keep moving. But here's the deal. You guys have to be able to do this stuff. Okay. Cotangent of 19 pi over 6. And my brain just registers big. That's big.
It's large. It's over 6.
So what can I do, since that's a lot bigger than what I want to deal with? Especially because on top of it being big, it's in that dreaded radians.
Subtract. Well, actually, subtract 12 pi.
I hate it.
Subtract
12 pi.
12 pi over 6 because we're going to subtract off once around the circle, yes?
Yeah.
So before I do anything, I'm going to say, okay, 19 pi over 6 minus 2 pi, because I need something to work with. And that's going to put me at 7 pi over 6. Aha, relief I say, because I can visualize the 7 pi over 6. And the reason I can visualize the 7 pi over 6 is because it's a smidge bigger than
Pi.
pi, which is 6 pi over 6, right? So if it's a smidge bigger than 6 pi over 6, then that puts it down here, yes?
Yeah.
So what about my reference angle then? How far is it from the x-axis? Pi over 6. Because I'm looking at how far is 7 pi over 6 from 6 pi over 6. And that is a pi over 6 distance. In quadrant 3. We're kind of quadrant 3 happy right now, aren't we?
A little bit.
That's right.
I swear,
Okay.
I think we should get out of quadrant. I thoroughly enjoy quadrant.
Okay, so what is my brain? So my initial brain is saying, what is the cotangent of pi over 6 in quadrant 3? But then my brain that memorizes the chart says, I don't know cotangent off the chart by memory. I know
Tangent.
tangent. So my brain can also say, what is the reciprocal of tangent in quadrant 3? So tangent of pi over 6.
Square root of 3.
Officially,
For tangent.
tangent is 1 over square root of 6, or 1 over square root of 3, right?
Flip
Really, that should say square root of 3 over 3 is what we normally talk, but that comes from 1 over square root of 3. But we really need cotangent, which is the reciprocal of that, and so that is square root of 3.
And it's positive because it's in the third quadrant.
All students take calculus. It is now a positive answer. Good news is, we stuck in quadrant 3 for a while, but we did a couple of cosines and a tangent. I was going to say we did a sine in there, but
quadrant.
if we're talking reference angles, we're not going to talk quadrant 1. Because quadrant 1 is just the answer's already on the, you don't have to think to get there. Cosecant of 495 degrees.
Subtract 180. Subtract 360. Or you can subtract 360. Sorry. 180.
Not or.
You should.
You should subtract 360 because you're subtracting once around the circle. And I know it gets confusing. Sometimes we use 360, sometimes we use 180. But this is, you're trying to subtract once around the circle.
Subtract 180 twice.
Yeah, I know. What is 495 minus 360?
135.
My brain can process 135. My brain is going to process that 135 is in quadrant 2. It's degrees, and I can handle that, right? So I do know I'm going to be working in quadrant 2. Now I need a reference angle.
45 minus 45.
How far is 135 from the x-axis?
45.
And so that we're doing 180 minus 135, which is 45. So my brain is thinking, what is the cosecant of 45 degrees in quadrant 2? But then my brain doesn't memorize cosecants. My brain memorizes
Sine.
sine. Reciprocal of cosecant is sine. So we're looking at the sine, the reciprocal of sine of 45 in quadrant 2. Okay, so sine of 45 is square root of 2 over 2, which comes from 1 over square root of 2. But the reciprocal of 1 over square root of 2 is square root of 2. And then cosecant is sine. Sine is positive in this quadrant. All students take calculus.
15. Still.
I hope your notes look neater than mine because,
Not really.
oof,
A tiny bit.
it's rough up there. I get it.
They needed the space a little.
I know. That's one of those things that, as I said, I hope to, before next year, kind of go through and reformat the notes. And this is one place where I would definitely give myself some more room because this kills me.
It wouldn't be bad
Okay.
if it just wasn't so much.
Well, and here's the deal.
A lot of it's written down. That's
The thing is, technically, when we do this, we're doing this in our heads. But if I just magically say, okay, to do secant of negative 3 pi over 4, we're doing secant of pi over 4 in quadrant 3, that's just like magic. And so here what I'm trying to do is write a little bit out so if you look back at it later, it won't be magic. You'll be able to maybe follow your train of thought.
It's
Maybe.
good when you do your homework on like a Sunday night.
Exactly.
I do.
Okay,
Just do your homework.
now, so that's a lot of practice with reference angles, okay? Finding that reference angle. What we're going to talk about now is kind of a special case. We're going to talk about something called quadrantal angles. I mentioned this yesterday. We actually looked at a quadrantal angle yesterday because I threw a couple in homework. Angle whose terminal sides lie along one of the coordinate axes are called quadrantal angles. These do not produce reference angles, so they're not going to produce a 30, 45, or 60 degree angle because we're talking about things like 0 degrees, 90 degrees, 180, 270, 360. So we're talking about our axes. Okay, they do not produce reference angles, so we have a special way of finding them based on the unit circle. So the point is, yesterday I drew that circle and I gave a side length of 0, which was kind of weird. This is our way to avoid having to draw a triangle and give a side length of 0. Okay? So, in an ordered pair on the unit circle, so if we are on the unit circle and it's not a bigger unit circle, first of all, realize that the radius is 1. Okay? So, on the unit circle, radius is 1. Now, when I say the radius is 1, that is your hypotenuse, right? Okay. Important to know here. The x value is the cosine value. The y value is the sine value. And all other trig functions can be found based on that information. Okay? So, you know what? I really should be on the next page here. Oh well. Unit circle, r equals 1. X value is cosine. Y value is sine. So what we're going to look at, so in an ordered pair that is x, y, this is always cosine and then sine. So when we talk about an ordered pair on the unit circle, the first value represents the cosine at that angle. The second value represents the sine at that angle. And so what that's going to help us with, sine is always your y value, because think about sine. Sine is opposite over hypotenuse, right? What is my hypotenuse always in the unit circle? 1. And so your y value is always going to be your opposite value. Your cosine is always your x value. Think about cosine, it's adjacent over hypotenuse, but that hypotenuse is 1. Adjacent side is always how far left or right you go. And so that's your x value. Tangent is y divided by x. Okay? Tangent is y divided by x. For instance, if we go over here and look, tangent of 45 is 1. Because what is sine divided by cosine? Square root of 2 divided by square root of 2 over 2 divided by square root of 2 over 2 is 1. If we go up to tangent of 30, sine divided by cosine, what's 1/2 divided by square root of 3 over 2? The 2's are going to cancel. It's going to be 1 over square root of 3. If we go down to the bottom, tangent of 60, sine divided by cosine, square root of 3 over 2 divided by 1 over 2. The 2's cancel in that scenario again. Square root of 3 divided by 1 is square root of 3. Okay, so important connection here to make is that tangent is sine over cosine, which translate here to be y over x. Okay, this is your opposite over adjacent. Okay, now let's look at sine of negative 270. Sorry, I'm trying to think how your unit circle does not have that. Okay. So, sine of negative 270. First of all, the challenge of where is negative 270?
Right there. No, it's not quadrant 4. It's this one.
Okay, none of these can be in a quadrant. FYI. They're all going to be on the line.
It's the top line.
Okay?
The x-axis.
Now, I would say, did I hear add 360?
Yeah, that's
Did I hear that in there? Let's do it. So, what is negative 270 plus 360?
90 degrees.
90 degrees. So what we're really going to be doing is the sine of 90 degrees. Okay, so there's my cute little axes here. Where is 90 degrees? It's straight up, yes?
Yep.
Does it make sense that is also where negative 270 would be if you went down and around?
Yeah.
Okay. Now, here's what I need you to think when we are at this point, is what would be the ordered pair on the unit circle here. If my radius of my unit circle is 1, how do you get to, like, just think in terms of coordinates. How do you get to that point? You go left to right, how far? 0. And you go up 1. So this ordered pair representing the point on this angle is 0, 1. Well, if that's 0, 1, what is the sine of 90 degrees? And why is it 1?
Because sin is always 1.
Sine is y, right? What is the y value? The y value is 1. So the sine of 90 degrees is 1. Now, your calculator would verify that for you. Okay?
It does.
Now, I have not... Okay. I think this is a good time to hand these out. I have another unit circle for you. And I know you have one in your notes, right? This is a slightly different version of the unit circle. Or not different version, just has different... If you go and like Google unit circle, there are so many different variations of what information they provide on. Now, this one I'm handing out to you right now because it has the ordered pairs on there for you to help you visualize that. Okay, I'm still going to ask the same questions, but this unit circle is yours. It's yours to write on. It's yours to do whatever with. Okay, we will talk about it. You want to hold on to it. It will be important later on, but feel free to make this help yourself as well. Okay. Okay. Let's talk tangent of 3 pi.
You can even do that. Subtract 2 pi. Yeah.
Okay.
Subtract 2 pi.
If you're struggling with where 3 pi is, take a circle off. 3 pi minus 2 pi is pi. So I'm now asking myself the tangent of pi, which means where is pi? That is the 180, yes?
Yeah.
And
Negative 1.
what is that ordered pair at 180?
Negative 2.
You go left 1, up or down 0. Does that make sense? Like, I don't want you to rely on looking at the unit circle. Just think logically. If you were graphing an ordered pair, you would go left 1 and then up or down 0. So what is tangent? 0 because y over x is 0 over negative 1, which is 0. Okay. Secant of 11 pi over 2. Your guys' doesn't have what looks like a negative on the 2, does it?
It does.
It does, but I think it's just like.
Okay, because that's not in my original notes. I think it's just a streak that is not negative. It's just a printing glitch. Okay. Because in my notes, I don't have that. So that's why I was a little confused. Now, what are your thoughts about 11 pi over 2? Why would we be subtracting 4 pi over 2?
Because that's 2 pi.
Because we're subtracting a circle away. So we're going to subtract 4 pi over 2. 11 pi over 2 minus 4 pi over 2 is 7 pi over 2. What's still true? That's still big, isn't it? Can we keep going? Yeah. Subtract again. Subtract 4 pi over 2 again, and now we're at
3 pi over 2.
3 pi over 2. Ah.
Yay.
That's my sigh of relief there, of like, oh, okay. Or maybe it's me being goofy. Who knows? But where is 3 pi over 2?
270.
That is the same thing as 270. How do I get to a point? By going down. We go left or right? 0. And
Down there.
down 1. So 0, negative 1. Now, so when we do this, we are thinking secant of 3 pi over 2. However, your brains know that secant is the
Inverse.
reciprocal of cosine. So what's the cosine of 3 pi over 2 going to be?
Negative.
Zero.
Wait, it's not.
The cosine of 3 pi over 2 is going to be 0.
My bad.
But we need the secant. We talked yesterday. What especially ends up being the reciprocal of 0? Undefined.
Yeah.
Now, and here's the deal. When we think about 0, 0 as a fraction is 0 over 1, right? So if you need to, you could think of this as 1 over 0. And 1 over 0 is undefined.
Error.
That's crazy.
Okay. We're doing okay with this stuff? Okay. Cosecant of 5 pi.
Subtract.
Officially, it's subtract 2 pi, which puts me at
3 pi.
3 pi. Subtract 2 pi again. Remember the other day we talked about that negative 99 pi? All the odds are always going to be the same, right? All the odds are going to reduce to 1 pi. All the evens reduce to 2 pi or 0. That's where we're at there. Okay, so we are thinking the cosecant of pi, but then my brain is going to say, I don't really think cosecant. I'm going to think the reciprocal of sine of pi. And maybe you don't need these little drawings off to the side anymore, but that's all right. You're still going to get them from me. Where is pi?
Left 1.
Okay. Pi is 180. It's the left side. When I move to that ordered pair, it would be left 1, up or down 0.
So the reciprocal of 0.
Right, but I'm just getting the ordered pair. I haven't given an answer yet. I'm just trying to always get you guys to write down the ordered pair. Or maybe you don't have to write it down when you do it, but that's what you need to think. And what is the sine of pi? 0. So what's the reciprocal of 0?
1 over 0.
Undefined. 1 over 0. We have time to get these last 2 in, I think.
Yeah.
We still have the backside. We're not going to get to that today, obviously. But cosine of negative 3 pi over 2.
Subtract 4 pi over 2.
Not subtract.
Add.
Add.
Because it's negative.
And here's the deal. If your brain can already go to where negative 3 pi over 2 is going to be, that's fine, right? But if you at all hit that point of, I don't know where it's going to be, then take negative 3 pi over 2 and add 2 pi. So I'm adding 4 pi over 2, which means I'm working with pi over 2. So we're doing the, what, cosine of pi over 2, correct? Where's pi over 2? That's the up one. Left or right 0 and up 1. So an ordered pair of 0, 1.
So equal.
Cosine of pi over 2 is?
1. 0. 0.
0, yes?
Yeah. I already wrote 1 and squared it, but I'll just switch that to 0.
No, sorry, you know. I'm like, no one was arguing you, and you were so confident. I'm
I was
like,
very confident.
did I mess up? Are we okay with 0?
Yeah.
Because it's the x value?
Sometimes
okay.
I just get it mixed up.
Okay. I'll get the mix up out of the system now, right?
I was looking at sign, so I was like, sure.
I'm like, no one's arguing her. What? Am I wrong here? That's what, when you guys don't start arguing the person that gives the wrong answer, I'm like,
Well, sometimes Mario and
Right.
Connor just argue for fun, so It's bad this
Okay, negative pi over 2. It's 3 pi over 2, right? I mean, you could just go straight down there. But negative pi over 2, if we add 4 pi over 2, we are at 3 pi over 2. So we are going to be thinking cotangent of 3 pi over 2. And that's one that I would just leave it as negative pi over 2, honestly. I know where that is, right? My brain doesn't do cotangents very well. My brain does tangents better. And this is said to each their own of how they do this, right? So where do we decide 3 pi over 2 is? That's the down, that's the 270, yes. Or negative 90. So that ordered pair, I would go left to right 0 and down 1. So 0, negative 1. She says undefined. I don't know. I haven't processed yet.
Negative 1 over 0.
Okay, yeah. Tangent would be y over x, right? So then when you flip it, it becomes 0 over negative 1, which is 0.
Oh,
Forget that one.
no, I flipped it. I just didn't think that.
0 on top is 0. 0 on bottom is undefined. Excuse me.
That's my mistake.
Okay. Again, you guys weren't arguing each other very much. It always
I
throws
was
me off when
totally
that
ready to
happens, but
I was like, Mario,
I'll
look
go
at the same answer.
I'm sorry.
Because I forgot to flip that. I agree.
okay, so
I just didn't see.
we're all making the same issues. Okay, so what I'm gonna say, I have 3 examples left to do that I haven't gotten done. I will say, I would suggest you start working on the homework while it's fresh in your head, but I will probably not make it due till Tuesday.
Okay.
So, excuse me. Monday, I'll finish these examples. You'll get some work time, and we'll also do some quiz prep. Okay? We'll make sure you guys are thinking on that.
What's it do?
So,
Main. Intel.